Okay, so I just received this a little while ago. The mailman dropped this off. This was sent in for free, no charge, for a review. And there'll be a link down below if you click on the description tab, depending if you're using the app or if you're on a computer. But if you look down in the description, there'll be a link to this little guy. I don't do a lot of review videos on equipment. I've done a couple radios, stuff that's being provided. Don't get me wrong, I do review videos on radios all the time, but they're either a customer's radio that I'm working on, or it's my radio, or something of mine. I don't do a lot of reviews on stuff that's just sent in for review, but I do a few of them. And usually it's only stuff that, honestly, I think people that watch my videos would find useful or something that they would be interested in buying. Now with the upcoming electronics course, test equipment is going to be something that if you want to do electronics, you're eventually going to need. And they contacted me about this. So like I said, if you click down below, it'll have a link to Pevono's website, and then a link to the actual on Amazon where you can buy this little supply. But they sent me an email, wanted to know if I'd be interested in doing a review. I said, I looked at it, I was kind of twixt between. I looked at the specs and I was like, man, you know something? That doesn't really look too bad. For the price, yeah. And something that was surprising was, I've never seen anybody do this before. I don't think ever, as far as at least test equipment goes, or well, at least when you're looking at something, let's say, on Amazon or eBay. And what that was, if you go to that Amazon link for this thing, they show you a picture of the inside of the unit on Amazon. Yeah, when's the last time an equipment manufacturer, other than maybe high-end equipment, which you're talking, $10, $50, $100,000 instruments, yeah, they're more than happy to show you the inside, what you're spending, that much money for. They'll show you the engineering that went into that. But a lot of times when it comes to cheaper stuff like this, you usually don't see that. They're not, they're just not that proud. It's cheap. But yeah, that was impressive. I thought that's kind of nice. You actually get to look at what you're buying, actual build quality on the inside. So I thought, I'll give this one a try. Now they gave me an option. I could either get the 3-digit or the 4-digit. Of course, I'm not an idiot. I'm going to get the 4-digit one to review. And that's apparently the only difference between the two models. So if you take the H off of the end, it would be a 3-digit. Add the H to the model number there, it's a 4-digit supply. And all that means is it'll have 3 digits there and 3 digits down here. So I got it today. I unboxed it. I've already had the cover off. I'll take it back off to show you the inside. And it actually works pretty good. I'm actually kind of impressed for the price. And actually, if you go on Amazon and look at similar units, anytime you go to Amazon, a lot of times they'll have similar items. You scroll down in that listing from other manufacturers and other sellers. This one seems to be lower in price than pretty much all the other ones, at least that were on the page as comparable devices. This one was like $10 or more cheaper than most of the other ones. Now, I actually had this thing cooking for quite a while at 5 amps. In other words, just dead shorted the leads, set the voltage up the whole way, turn the current limit up the whole way, and basically just walked away from it. And yeah, it was fine. It had absolutely no problem doing that. I then ran it on a load, and actually this thing is, it's touchable again. I had this thing up to like almost 400 degrees. This is a 10 ohm, actually there's the box for it. It's an old antique, but yeah, it's a good high quality old IRC, but it's a 10 ohm 75 watt variable wire wound resistor. I have no idea what the resistance is that it's currently set at. Actually, we could figure that out by having voltage and current. Ohm's law, we could figure out the resistance of this. But yeah, wherever it's at, I just left it there. But then just attached it to the power supply, and Now, one thing I noticed I really like about this, I'm sure you can, I'm not sure, but fan speed. You hear that? You can hear the fan. But it goes away. Comes back. Here's the real kicker. As I turn the voltage down and the current, the fan speed decreases. So it is an actual variable speed fan. It actually changes. Which is nice. I I have an expensive HP power supply right there. That doesn't do that. I turn that thing on, that gigantic jet turbine for a fan that they have in that thing. When that thing comes on, it's just humming at full speed all the time. You know, and just like communications test sets, signal generators, spectrum amp, a lot of this equipment all has fans in it. So, you know, if you're going to get into electronics, you're going to quickly find that your room, depending what you have turned on, can get really loud with background noise. So anytime we can get a piece of test equipment that either just has a quiet fan to start with, you know, it's large size, high volume, but it's a slow speed, so it's quiet, or something like this, where it's only putting out noise when it's under really heavy load, I think that's great. Like I say, I've got power supplies like that HP over there, which honestly, that thing's... This is close, is comparable to that. In voltage and current, it's very close. This is 0 to 30 at 5 amps. Now that one's a lot higher current, but because that one's kind of hard to describe without going into the details of that one. But that's a 200 watt power supply. But it's a maximum 20 volts up to 30 amps. But main thing is it's 200 watts. This one will do 5 amps at 30 volts. That's 150 watts. So this thing will do darn close to the amount of power that HP will do over there. And it's in a lot smaller box. You know, now granted, that one's orders of magnitude more in expense. Just the build quality in that is really... Actually, I did a repair video on that one. That's the one that the transformer got broken in transit. All of the wires got ripped out of it, and I repaired it. But yeah, this little guy here, honestly, is really close to specs with that one. This actually has more resolution on the meter than... Because this one's has a 4-digit display. So yeah, it actually has higher resolution. And it seems to be working fine. Like I say, I've had it bogged down under load for an excessive time. I've had it hooked up to an actual load, not just shorting the test leads. Actually, you know, my resistor's starting to warm back up. So, you know, let's crank the voltage back up to like 13.8. Oh, I got to set. Now, that's another thing. You have adjustable voltage and current. And you'll see as I turn the voltage up here, nothing's happening. The voltage is not increasing anymore. That's because it's switched over into constant current mode. So you have constant voltage, constant current. Once you get to a certain... You got your current set, like right now, it's set to 1.286 amps. Is the maximum current that this thing will supply to whatever it's attached to. And it switches over to that constant current mode. The voltage will not increase. It's just clamped down at 1.286, 287 amps. But as you see, as I increase the current now, the voltage is going to start to increase as well. So, you know, I turn the voltage back down here. We get to a point where the voltage starts becoming adjustable again. But that's because we're switching between constant voltage and constant current. But that's one thing that's nice about using a supply like this. If you're having a problem with a circuit... So it's up off the bench because this thing's going to get really hot. It's going to take it a little while, 1.3 amps, but still, that resistor is going to get really smoking hot again. Don't want to be laying my arm on it for starters. But if you have a short circuit inside of a radio, a television, VCR, it doesn't matter what it is, you can maybe isolate it down to a certain circuit in that piece of equipment. But you're having trouble tracking down what it is because it keeps blowing a fuse or, you know, whatever the protective device is in that whatever widget you're working on. A lot of times I'll use something like this, a current limited power supply, where I can set the current limit to, let's say, like 100 milliamps. If I know you know, the whole radio, if I don't know, there's something in a radio's bad. As soon as you hook up the power cord and you turn the radio on, blows the fuse. How do you diagnose that? That's where something like this comes in. You can, you know, with let's say a CB radio, you could set this. So, you know, most FCC certified CB radios are going to have a 3 amp fuse in the power cord. So what you could do is you could use something like this, which will supply up to 5 amps, but you could turn it down to, let's say, 300 milliamps. You know, 100 milliamps, or a very low current. It won't blow the fuse. The components that's actually shorted out inside will slowly start to warm up, so if nothing else, just with your finger doing this, you know, like let's say this resistor here, you know, you can feel it. Ah, it's getting hot, and that would be, well, that must be the bad part, because that's the part that's getting nuclear hot inside of the radio. Like I say, it's really nice for tracking down, and you know, you can disconnect power rail lines, and let's say if you're working on a radio, you've tracked it down to a certain circuit, disconnect where it's picking up power from the main power rail on the radio, and run just that circuit off of this power supply. That's where this stuff like this is handy. Now I've had this hooked up to an amp meter. Surprisingly, let me disconnect this resistor. So let's just set the voltage to 13.8, because here at this bench, that's a lot of times what I'm using. It's 13.8 volts, because of course working on radios. So let's set the meter back here. We want to check the accuracy of this. And let's see, that's my other one. Oh, my ground's right here. So that's a dead short. So 5.2, so that's dead short. Like I say, you can see it doesn't matter what I do with the voltage, because we have a dead short. It's switched over to constant current. But yeah, this supply is now putting out 5.261 amps. That's impressive. 5.2609 amps. Wow. 2.6. Okay, they're reading exactly the same. It's fluctuating a little bit. That is impressive. Now, one thing I did note was it's not that accurate over the entire range. So if we turn the current down now, let's go to like half of its rated current, 2.5 amps. Use the fine adjust here to drop it down. So there's 2.5 amps. We can see we're at 2.4947. That has more digits of accuracy than this, because this is only 4 digits. But you can see, but that's within a couple thousandths of an amp, or a couple milliamps, you know, accuracy-wise. That's still pretty good. Like I say, it's dead nuts on at full scale, but it does, that accuracy does, it's kind of logarithmic. It drops off. It's not linear over that full range. So the lower you get in current, so, you know, if we drop down to a really low current level, like 200 milliamps, let's say, close as I can get there without fiddling with it for a half hour. So, you know, there's 201 milliamps, and you can see we're showing 192. That's still really close. It's still within just a couple milliamps of what this is showing. So, yeah, it's dead nuts on, at least this one, the one that they sent me, is dead nuts on at full current limit. And once you get down towards the bottom end of the scale, yeah, you get a few milliamps of discrepancy, but honestly, that's impressive. For something, the price, what they're selling these things for, that's fairly impressive. The voltmeter, I actually tested it as well, you know, with, ouch, that hot resistor that I just picked up. Under load, I was checking voltages. Again, it's accurate. Now, the one thing you're going to find if you do something like that, and actually I can demonstrate that. So let's get the, we'll just get this resistor hooked back up. Let's see, that would be this clip. And that one. So let me set the voltage back up. I'll set that at 13.8 again, or roughly thereabouts. And let's set the current limit. Let's say about 2 amps. Right about there. And I'll attach it to the load. So it's now attached to the load. And we'll hook up a voltmeter. And you're going to see a difference. And this is just something, switch back over to voltage. And this is just something you need to be aware of. If I attach the voltmeter down here, you're going to see 13.8 volts over there. But with the voltmeter attached at the load, you can see there is a discrepancy. That's the one thing you have to remember when you're using a device like this. This is a cheaper supply, so it does not have what they call a sense line. The much, much more expensive power supplies like that have what they call sense lines. So there's a big terminal strip on the back of that thing. You can do all kinds of fancy stuff with that. Actually, that even has HPIB interface. But one of the important ones on something like that, which is a like I say, very expensive, is it has a sense line. So there's wires on the back of that that can be remotely attached, just like that external voltmeter is there, can be attached at the point of the load, because the voltage is going to be different here than it is here. There's no load really, here. After it goes through all of these long wires, these just clipped on connections, it could be be adding a little bit of resistance and whatnot into the circuit. The voltage is going to drop a little bit out here, and you'll see that discrepancy between the voltages. Actually, that it's this meter is measuring the voltage inside the supply, and it is 13.81 volts inside the supply and at the jacks. But by the time you get done going through your test setup or whatever you're running it off of, all the wiring and circuitry and whatnot, the voltage may drop down a little bit out here. So this doesn't have a sense line, and with that HP, what you would do is run those sense lines out to the load, and then the power supply corrects for that. It will bump the voltage up. So there'll actually be a little bit more than, let's say, 13.81 volts here at the jacks. But they will be exactly 13.81 volts out here, and it'll display, like 13.8 there now. I've got the knob. It's just fluctuating around a little bit, but it accounts for that. Something like this isn't going to have it. Like I say, it's not a couple $1,000 power supply. It's really cheap, but for the money you pay for this thing, I think it's probably worth it. I was surprised the size format. Like I say, the variable speed fan, I think, hey, that's great, because like I say, that's as long as you're not running it at full power, and even then, just you disconnect the load, the fan kicks off. So yeah, you don't have to listen to that annoying fan hum. It's not that loud to start with, but yeah, actually, what's this resistor up to? I say it doesn't feel too hot. I can pick it up. Yeah, right around 200 degrees Fahrenheit. So yeah, it's hot, but it's not enough to bake the skin off my hand. So yeah, the only other thing I want to... Actually, I just dawned on me. I had not checked yet. Hook the voltmeter back up here. I wanted to check the AC ripple. So it's showing like 7 millivolts AC ripple. Now actually, let me apply a load, because you have to remember, that's with nothing attached. I want to see what the actual AC ripple is under load. So now we're putting out 13.8 volts. It's putting out 1.37 amps. We'll reattach the voltmeter here and see what we have for AC ripple under load. Nope, so it's still right around there. 8 millivolts. 8 point, it's going to fluctuate around there a little bit, but yeah, about 8 millivolts of ripple. Actually, we look at the spec sheet really quick, or actually just the box. And there it is, and it's this model right here. That's like I say, the 4-digit supply. But the spec sheet there, if we focus. Are we going to focus? There we go. Ripple and noise, less than 3 millivolts RMS. I'm showing 8, but still, that's not that bad. 8 millivolts of ripple is not really that bad. So there, if you want to just really quick look at the specs it has. Like I say, this is the 4-digit. So it's a light little supply. Like I say, I think it works pretty good. I'm impressed for the money and the size. I like it. I will probably use this thing, and just if nothing else, to torture test it over a period of time. But I think it works really well. Like I say, the ripple voltage does exceed the spec sheet a little bit. Nothing that's grossly inaccurate. I mean, it's not like it's got 100 milliamps or 100 millivolts of AC ripple. It's got a few millivolts more ripple than as advertised. But yeah, nothing excessive. Now, one other thing I've got torn apart over here. This does come with a little short wires. You'll notice there's nothing on the other end, because I just wanted to see the quality. So I took the ends off because they just have a set. They're cheap. This is a lot lower quality than this. And that's actually a lot of times where, with stuff like this, the accessories will be the failure, and this is no exception. The way they assemble these power cords, they need to do something else. Actually, I didn't even pull the boots back on these to see. Are those? Yeah, they're not soldered. They're just crimped on, which is fine, but still, I'd rather see a soldered connection there. But that's not bad. There's lots of copper wire touching there. It's crimped. These the way they have the banana plugs attached to here, the wire can only go in like that far. You see there's a hole, and what they do is they put a set screw through there, okay? Well, can you see, where is it? Right there. You see that round thing? Well, that's where the end of that screw was not making contact with any wire whatsoever. The set screw was into the insulation. And that's it. And the other one's the same way. Now this one, they actually had the wires folded over. But again, the set screw, get it to focus, was not actually touching any of the strands of wire. So if you do get one of these, now honestly, you could see I wasn't using there. I was using my own power cords, good high quality. This looks like the same cord that comes basically with a FCC certified CB radio. It's the same kind of twin lead cord. But yeah, if you do get one of these, probably what I would do is loosen the set screw, pull the wires out, strip a little bit of insulation off, twist the wire up, fold it back over to double it up. But when you install it, make sure that the insulation does not go in farther than the end of this jack. Because if you get the insulation in there, then you're going to get the possibility of what they had here, which is just going to be the wires just kind of touching in there, and yeah, hopefully making a connection. They're not getting a good mechanical connection. So yeah, that's the only thing I would suggest there. Just cut the ends off, twist it up, fold it over to kind of bulk the wire up a little bit more, or honestly, better yet, just solder it in the hole. If you've got a heavy enough soldering iron to heat this up, just solder it in there. Just remove the set screw, solder it in there. Now, you will have to put actually the set screw back in, because honestly, that's what holds the the outside on. These aren't like most of the ones you'll normally see where the ends screw on a lot of times. But yeah, just do yourself a favor. Check that. But that right there is not enough to kill, make me give this power supply a bad review. The power supply itself is pretty nice for the money. Like I say, it's the cheaper of the ones that are on Amazon. It looked like, from what I, with some quick searching, price-wise, it was cheaper than other ones that are comparable in size and specifications. And like I said, just the size-wise, there's my hand. It's a tiny little guy. So it doesn't take up hardly any space. And like I say, if you think about that HP power supply over there, if you watch the video on that I did of repairing that thing, you saw how deep that thing is. It's really deep compared to this. It's probably, 2 times the depth. And you can see how much physically larger it is height and width-wise than this thing. And it's only 50 watts more power than this little tiny thing. Now, does that power supply over there have a lot more features than this one? Yes. But for the average person, especially if you're just starting out in electronics, you don't need those fancy features. This one does it all. So here's the inside. Good, clean layout. Doesn't look all butchered up. Now, one thing I did notice was it actually looks like they've made some upgrades to it, and there is a possibility that actually that might be one way to take care of that problem, even, because those are. I just need to do some looking here at some capacitors. What do we have? 4. Oh, a little flashlight. Okay, so that's an output, and that's an output capacitor. Okay, so yeah, they actually say on the, and it's in Chinglish, but again, if you look at the box here, built-in 4 filters, capacitors, among which 2 pieces of 35 volt 470 microfarad, again, capacitors on the output. Yeah, that's, wow. That is Chinglish at its best. So, yeah, they mean capacitors. But yeah, 2 pieces, 35 and 470 microfarads. But notice there's some empty holes here, and that's what I was just looking to see. These are the 2 470 microfarad capacitors, and you can see, okay, there's one connected there, and the other one's here. It's right there. And those are attached right to the wires that go down to the banana jack board here. So that's those 2 output filter capacitors. But notice there's some empty holes there. So if that 8 millivolts that I just measured was excessive, that would be fairly easy to just add some extra. I mean, for starters, even if you didn't have holes, you could just stick bigger caps in there. You could stick like 1,000 microfarad. And honestly, it may be what I'll do is I'll just desolder those 2 holes where there's nothing at, but you can see those 2 holes are attached to the power rail, and actually there's holes right there. It's actually not meant for. No, that's not to ground, though. I was just trying to see if I could stick another one there. But yeah, it would be easy enough to just add, because there's already a footprint for it. And actually, there's even a footprint here for another capacitor. Now, these are 1,000, I think. And they're Cheng X. So yeah, normal Chinese. Like I say, it's obviously built in China. But there's even a footprint there. So you could add 2 filter capacitors, and you could probably cut down on that little bit of AC ripple voltage even more if you wanted to. But 8 millivolts, like I say, that's not that bad. Build quality, like I say, board layout's nice. Probably more than I was expecting for the price of what these things cost. I do see 2 trimmers right there. So those are probably going to be the adjustments for the meter. Or they could be. No, because there's another trimmer there. So yeah, those are probably adjustments for the meter itself. And is that a? Okay, I'm just looking at some of the parts here. So I do see there's footprints. This is obviously used in other applications, because actually there's some footprint. It just might be these. Now that I look at it, see, there's trimmer resistor there and a trimmer resistor there. Well, what's that? RW1, RW2. Those are footprints. It looks like that, and it looks like the traces run right up to these 2. So probably, depending, these boards I assume are probably the same if I had to guess. But a lot of those other ones that are being sold, similar size, ratings, and whatnot, they probably all made in the same factory. And depending on who they're making them for, like in the case of this one, Pevono, they went with the higher precision 10-turn potentiometers. But they have footprints for the single-turn little trimmer potentiometers down there. So yeah, probably they're universal, and depending on who they're building these things for, it's what parts they put in it. But yeah, this one has the 10-turn. It's nice to see. Like I say, instead of the cheaper, just little, quarter, or, not even 1 full turn, but the normal trimmer resistors. So that's kind of nice to see. The one thing I did notice is the isolation from AC. Of course, this has a power switch. It goes up there to the jack, comes back, and actually, and I'm probably going to do that myself, I would like to see insulated terminals on here, because do you see that? That's AC. There's the jack right there, okay? Red wire comes up to the switch, and that's come out of the switch. Look how close that is to that screw that's sticking up there. If that was pushed down, if you were working on this and got it down a little bit too far, yeah, that should have those should be insulated terminals. Now, it is grounded though, so it's a normal jack, and it does go straight to the chassis ground. Yeah, that standoff is welded. Yeah, that's a welded thread cert right there. And look at that. They even went through the trouble of, instead of using cheap little stick-ons, they even have welded on a little wire thing there to prevent the wires from moving around. But yeah, I'd like to see, even though it's grounded, I would still like to see that insulated. That's just a little bit too close for me. And it does not have isolation slots cut into the board, but if you look at the spacing, how far apart those traces are, yeah, I don't have any concerns really of arc flash or anything arcing over because there's a lack of isolation slots, and if you're not familiar with that, that's where they actually grooves are cut into the board to completely isolate parts of a circuit. Like I said, I don't really have too much fear of that because the traces are just physically so far apart on this. Yeah, the only thing I see that I might, like I say, be concerned about, the terminals. I'll probably just pull all these off because they're just spade connectors. They're push on. I can pull them off, slide a piece of heat shrink tubing on there, shrink it, and just push them back on. But yeah, other than that, I think it's decent quality. For the amount of money you're paying, the little thing works good. Like I say, I had it under load for dead short for almost a half hour. Worked fine. If that 8 millivolts of ripple voltage is a little bit too much for you, like I said, I think that'd be easy to fix. For me, the 8 millivolts of AC ripple isn't really that much concern for me, but yeah, it's got the holes, so yeah, if you wanted to add some capacitance, the hard work's done. Where to put them. So there you go. Now, like I say, if you look down below, I'll provide the link to the company's site and the Amazon listing. But and this did have I took it off. It had that little clear film over the lens when I started. I pulled that off. You know, the anti-scratch material. But yeah, size, great size. Oh, this is multi-voltage, so it does work off 110, 220. So you just slide a little switch there back and forth. Does have the built-in fuse holder in the AC power socket there, so it is fuse protected. Yeah, looks like you would expect. Any AC/DC, type supply. I don't see anything out of the ordinary. Everything looks like what I'd expect. Like I say, the only faults I can see, that cord, I'm never going to use it anyhow. But if you are, just take the terminals off and make sure the set screws aren't into the insulation. Make sure they're actually on wire. I might recommend putting some heat shrink tubing on the jacks. I'm paranoid though. Even there, look at that. Matter of fact, or that ground. Oh, that's ground, so that wouldn't matter. I was going to say, look how close that is to the metal right there, but yeah, that's the ground pin, so, and that should be, yeah. But still, like I said, pull them off, put some heat shrink tubing on them, and I think you'd be fine with that. Like I said, I'm just a paranoid person, rather safe than sorry. So, there you go, and I'm not sure how you pronounce that either. Pevono, yeah, I'm assuming Pevono, one of those. But this is the PS305H, which was 4-digit, and the PS305 is the 3-digit. So the only other thing was, complaint-wise, I did notice, you'll see there's a double banana jack sitting here. Actually, that's a shorting bar. But the one thing I would suggest to the manufacturers is you need to fix this. Double banana jacks don't fit. Or, hold on a second, let me just turn around and grab some. Yeah, on rails like this, I'll use a triple banana plug. I've got triples. So, I make up power cords. I can have my, my positive, my negative, and the ground, the earth ground. And that's the nice thing. The power supply is isolated from earth ground, but it does have a earth ground terminal in the front. And this is standardized. The spacing, these either 2-terminal or 3-terminal, that is a standardized spacing on these. You look at any type of test equipment, like the Sencor over there, it has double banana jacks on it. Lots of, the B&K piece of test equipment down there, there's double banana plug jacks there. There's just so much stuff built over decades and decades have used these standardized spacing on this. It won't fit. Now, I kind of know why it's like that. It'd be nice if there was a way to fix it. They'd have to redesign this whole front panel. They've got enough space down in there to move that, between the power switch there. They should be able to, like I say, they'd have to completely lay out this little ridge here. They'd have to move it over, maybe even move the AC switch over a little bit. But if they could space these jacks out to where you could use a triple banana plug, that would be nice. And another thing is, provide a shorting bar. When you buy a higher dollar, and it's not going to cost much, so this is talking to the manufacturer that makes these things, I would suggest including a shorting bar. Usually when you have something like this, you have the negative and the positive, and you have an individual isolated earth ground, they will provide you with a little bar. And you power supplies I've used over the years, you may have seen that, some of them. Sometimes you'll see there's a little metal tab, a little bar hanging down underneath here. Or you'll see that there's a solid metal, there's something solid metal in between these two jacks. That's actually provided with the power supplies. And what that's meant to do is, you loosen up because these are also screw terminals. But you can just slide that little shorting bar over there, then you tighten it down, and it connects the negative to the earth ground. Like I say, sometimes you may want an isolated power supply, you want it isolated from your earth ground. Well, then you just loosen up the jacks, you drop the little bar down, it just dangles under here, and then you have an isolated power supply. But yeah, I would suggest including that. The other thing is, if possible, redesign this layout so normal banana plugs will fit, because even the two won't fit. It's still even that. Yeah, it's just too far apart. Just won't fit. So yeah, that's just a little gripe. That's no biggie. Like I say, you just use cords like I was using with just the individuals, or like the ones that they provided. You don't have that problem with those. But yeah, if you're going to be using pre-molded ends, they ain't going to work with this supply. And a lot of the cords that I have here and I use have I have little fixtures all over the place like this. But of course, the spacing on those is set up for the standard spacing on banana plugs. So there you go, Pevono power supply, model PS305H, 4-digit, 30 volt to 5 amp. I think it's a win. It's got a few little complaints. Nothing major, nothing that would prevent me from buying it or recommending it to somebody. If the manufacturer's watching, I'd use insulated terminals. If you could do something about that, would be appreciated. That's not required. And maybe do a little bit better job putting these ends on those cords. Other than that, yeah, for the money you're paying, I think that's a good price. Good working supply, so hope you enjoy. Okay, just a really quick little add-on to the video. Did want to make a separate one. So, before I put it back together, I did put heat shrink tubing on the AC power lines. Just makes me feel a little bit safer personally. Like I say, the cabinet is grounded, so I doubt that'd ever be a problem. But like I say, I'm a paranoid person, so better safe than sorry. The other thing was I mentioned about maybe possibly upgrading the filter capacitors on the output. I did that. So I removed the two 470 microfarad 35 volt electrolytic capacitors that were actually in there. Again, being a little bit paranoid type person, this has a maximum voltage of 30 volts output and a 35 volt cap. So yeah, I always uprate capacitors on voltage for stuff like that, so I stuck in. But I didn't just replace the two. Remember, it also had the empty footprint for another capacitor. So I took out two 470 microfarad 35 volt capacitors, and I installed three 1000 microfarad 50 volt capacitors. Now, they're good high quality. These are Chong-X, the standard thing you see in most Chinese products nowadays. But yeah, I stuck in, and they are, all the capacitors in this, I will say, they are, I think even these green ones are too. Yes, they're 105 degrees C. So all the black ones that were in there, and these, if we ever get it to focus, probably not. Hocus pocus, focus. Yeah, 105 degrees C. So yeah, they are high temp caps, but yeah, I stuck in Nichicons. And what are the results? So with 1000 microfarad 50 volt electrolytic caps in there, and I just had the voltmeter attached directly to it with no load. 0.5, yeah, something, it's bouncing around there a little bit, but let's just say 0.5 millivolts, so a half a millivolt. Yeah, we went from like 8 millivolts to about a half a millivolt. So yeah, if that is a concern for you, depending on what you would be using this for, if 8 millivolts of AC ripple voltage is too much, you probably didn't. I honestly probably didn't have to replace these. If I had just installed an additional 1000 microfarad cap in that empty position, it probably would be close to this. Because remember, these are just in parallel, so, capacitance adds. So you would have had 470 plus 470 plus another 1,000. So you would have, more than doubled the existing capacitance. And I did way more than that. Like I say, we now have 3,000 microfarads of filtering on the output. Other thing is, you'll notice there's a CB radio turned on back there. So let me turn the power supply off. And it's one of the things you have to remember with anything with a switch mode supply. Everything has it nowadays. Computers, plasma there's just so much electrical noise nowadays that we have to contend with. And power supplies are one thing that can cause problems, serious problems in the RF spectrum. So, of course, I work on CBs, so I wanted to turn one on and see if I turn this thing on, is it going to wipe out that radio? So that radio is actually hooked up to an antenna. And when I turn this on, nothing. Now, I'm not running the radio off of that right now, but they're all attached to the same power line. So, yeah, no noticeable... There's no noise being generated out of this thing that are affecting that radio. Now, having said that, does it affect any radios? Yes. So if I grab the remote control here, and I turn on the iHome up there to AM radio, okay, whatever station that is, and then we'll turn on the power supply. Gone. It wipes it out. Yeah, it just... Yeah, it just pretty much destroys normal broadcast AM radio. Now you have to remember, that's operating at a much lower frequency than that radio over there. That radio is operating in the 27 megahertz range. The station I had that on was somewhere around a megahertz, like 1.2 something, because it was like 1,000. I actually just turn it back on for a second. What is that? 1280, so 1.28 megahertz. So, yeah, at the lower frequencies, this thing is just way... And like I say, it's not like I'm running that off of this power supply. That's just either noise being emitted through the cabinet or backfeeding through the power, because everything on this bench is all attached to the same... main power supply, the AC wall outlet. So it's either backfeeding through this power cord in and then up to the radio, or it's just being emitted out of the cabinet and again getting into the in through the antenna. But that is something to be aware of. Appears to be fine for CB band, so 10, 11 meters. Yeah, this thing would work fine. Doesn't seem to add any noise. But AM radios, so if you work on little AM receivers, yeah, this is probably not a good idea because this thing's going to wipe it out. So I'm going to have to assume it's not going to be the 455 intermediate frequency, because AM radios have for decades, pretty much since almost the inception of AM radio, have used 455 kilohertz as an IF, one of the main IF frequencies. It's one of the reasons CB radios, so many types of radios use 455 kilohertz as an IF, is back in the early days when two-way radios first came about, all they were doing was just basically taking a lot of parts that were used in stuff like that, an AM radio, they're parts that are already being manufactured, and just used them in their radios. Well, it's still the same today. They use the same 455 filters in a radio like that might be in a radio like that. So so because it's not affecting this one, I'm going to say it's not the 455 kilohertz that's where it's being bombarded by where the frequencies come. I'd have to do some RF snipping with an RF probe on the spectrum analyzer there, but yeah, I thought I'd add that on. CB 10 meters, this power supply should work fine. If you work on AM radios, forget it. It just completely wipes it out. So there you go. I thought that would be helpful to let you know, just just in case somebody wants to work on AM radios and ends up getting one of these things. Yeah, it'll work, it'll power it, but yeah, it's going to completely blow out the receiver on it. Or, good example, I listen to AM radio during the day. I can't use this. or at least I'll have to turn the radio off while I would use this, because it's going to wipe out the radio station. Now, I may even play around with putting some snap-on RF chokes on this power cord to see if maybe, like I say, it could be backfeeding through this power cord. And sometimes that'll help. Just that I might even use some big ferrite cores where I put a couple loops of this, through a core, or like I said, I can try the snap chokes and see. But that might help. But yeah, it's really, really noisy on a normal AM radio.